Something spotted our solar system's newest visitor 10 full days before any human being knew it existed. Not a satellite, not a warning system, a telescope that wasn't even supposed to be watching yet. And when scientists finally went back through the data, they found it sitting there, already captured, already moving, already being ignored by everyone on Earth. This is the story of the Vera Rubin Observatory, the most powerful eye ever pointed at the sky, and what it has already started finding in the dark corners of our solar system that nobody was prepared for. For years, this project existed only as blueprints, funding disputes, and a mountain in Chile waiting for its purpose. Now it is awake. And what it captured in its very first hours of real operation has quietly rewritten what astronomers thought was possible. But here is where it gets strange. The most unsettling part of this story isn't what Rubin found this month. It's what Rubin had already found, without anyone realizing it, a full year earlier. Let's go back to the beginning, because the beginning is where the real shock is hiding. The Vera C. Rubin Observatory sits on Cerro Pachón, a mountain in Chile, chosen specifically because its skies are among the darkest and clearest on the planet. Inside it houses the largest digital camera ever constructed, a 3,200 megapixel monster the size of a small car, built through a partnership between the U.S. National Science Foundation and the Department of Energy. This isn't a telescope that looks at one thing at a time. It is designed to photograph the entire visible sky over and over every few nights for 10 straight years. Thoughtful minds spent 2 decades and roughly $700 million building a machine with one singular purpose: to catch the universe doing something it has never let us see before. Read that again. 10 years. Every few nights. The entire sky. That is not a research instrument. That is a surveillance system for the solar system itself. On June 30th, 2026, after years of delays, engineering setbacks, and endless recalibration, Rubin officially began its real mission, the Legacy Survey of Space and Time, or LSST. Every 40 seconds, the camera captures a new, detailed image of the sky. Every single night, it produces something in the range of 10 terabytes of data. And every single night, it generates up to 7 million alerts. Automatic flags for anything in the sky that has changed, moved, brightened, dimmed, or appeared where nothing was before. 7 million alerts in one night. Think about what that actually means. That is not a telescope quietly admiring stars. That is a machine built to notice everything that moves. And it is now watching the sky more closely than any system in human history ever has. But here's where it gets worse, or depending on how you look at it, where it gets far more interesting. Before LSST even officially began, before the real mission had even started, Rubin was already in a testing phase called science validation, essentially a shakedown period where engineers check that every mirror, sensor, and processing pipeline is working the way it should. This is normally the boring part, the part before the real science starts. Except in this case, during that supposedly uneventful calibration window, Rubin's cameras caught something that nobody on the team was looking for, something that, at the time, nobody even noticed was there. On June 21st, 2025, 10 days before the rest of the world had any idea it existed, Rubin's instruments photographed an object streaking through the outer solar system. Nobody flagged it. Nobody realized what they were looking at. The pipelines designed to catch fast-moving objects weren't even fully operational yet. So the object sat there, buried in raw calibration data, completely invisible to human eyes, while it kept moving closer to the sun. 10 days later, on July 1st, 2025, a completely different telescope network, the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, built specifically to hunt for objects that could threaten Earth, spotted the same object independently. And when scientists analyzed its trajectory, they realized this was not an asteroid, not a comet from our own solar system, not anything that belonged here at all. Its speed was too extreme, its path was too straight, too sharp, too impossible for anything born in our solar system. It had come from somewhere else, somewhere outside our star system entirely. This is not chaos. This is one of the rarest events in modern astronomy. The object was named 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system, after Oumuamua in 2017 and Borisov in 2019. And here's the detail that should make your skin crawl a little. It had already been sitting inside Rubin's archive, unnoticed, for 10 full days before anyone on Earth knew it was coming. According to the astronomers who eventually went back and dug through the commissioning data, if the validation survey had simply started a little earlier, or if the analysis pipelines had already been switched on, it would not be called 3I Atlas today. It very nearly would have been named 3I Rubin, discovered not by a dedicated planetary defense network built for exactly this purpose, but almost by accident, by a telescope that wasn't even trying yet. Sit with that for a moment. The most sophisticated sky surveillance system on the planet detected an interstellar visitor before anyone was looking for one, and still almost missed it, buried inside its own data, simply because no one thought to check. What most people are not seeing is what this actually reveals. It's not just that Rubin found something rare. It's that Rubin proved, in its very first uncalibrated breath, that objects from outside our solar system can slip through our defenses completely undetected. For days, potentially longer, even when one of the most powerful cameras ever built is technically already photographing them. And this is where everything changes. Once astronomers realized what they had, they went back through the archive and pulled every frame Rubin had captured of the object between June 21st and July 20th, 2025. Nearly 100 exposures in total, forming an accidental nightly time-lapse of an interstellar comet crossing our solar system, weeks before the public even knew to be curious about it. Those images showed something scientists hadn't expected. The object already had a coma, a hazy cloud of gas and dust surrounding its nucleus, meaning it was active and changing even at that early distance from the sun. Its coma grew from roughly 13,000 kilometers wide on June 21st to nearly 19,000 kilometers wide by July 2nd, expanding day by day, evolving in real time, completely unnoticed, while humanity went about its business unaware that a visitor from another star system was already brightening in our archives. Later, more advanced observations from Hubble, from the Very Large Telescope, from missions never designed to look for anything like this, began refining what we actually know. Early estimates put the object's nucleus at roughly 20 kilometers across. Then, Rubin's own data shrank that estimate to about 10 kilometers. Then, Hubble shrank it again, down to somewhere around 5.5 kilometers, with some estimates suggesting the solid core could be as small as 300 meters. Each new dataset didn't just refine the picture, it changed it. The size kept shrinking, the uncertainty kept growing, and every revision was a reminder of how little we actually understood about the thing traveling through our neighborhood. According to informed analysis published by teams studying its chemistry, 3I Atlas behaves differently from anything we've seen before. Its coma showed a reddish tint linked to organic compounds baked in by cosmic radiation over unimaginable spans of time. Spectroscopic studies detected atomic nickel and cyanogen gas boiling off its surface at distances from the sun where most comets stay dormant and frozen. Other researchers found it releasing carbon dioxide at oddly high levels, hinting that its interior chemistry might be fundamentally different from anything born in our own solar system, possibly formed in an environment far colder, far more ancient, shaped by a star that may not even exist anymore. Let that settle for a second. Some estimates place the age of this object's parent system in the range of billions of years, old enough that the star it once orbited could have already died before its fragment ever reached us. This is not an object. This is a message from a system that may no longer be there to send one. And it kept surprising scientists at every stage of its journey. As it made its closest pass by the sun on October 29, 2025, multiple space missions scrambled to observe it, not because they were built for this, but because they happened to be close enough to try. NASA's Psyche spacecraft passed within about 45 million kilometers of it in September. The European Space Agency's JUICE mission, en route to Jupiter's icy moons, managed to catch it in its instruments in November, even though redirecting spacecraft resources for an unplanned visitor is neither simple nor guaranteed. Europa Clipper may have passed directly through its ion tail in early November, potentially gathering direct evidence of an interstellar object's chemical signature. Data that, if confirmed, would be unlike anything ever collected before. Think about what that means. A comet from outside our solar system passed close enough that multiple active NASA and ESA missions, spacecraft built for entirely different purposes, aimed at entirely different targets, had to make split-second decisions about whether to turn their instruments toward it. Humanity wasn't ready for this visitor. We improvised. And even improvising, we still learned things about it that no textbook could have prepared us for. But here's the part that deserves its own moment of tension. As word of 3I Atlas spread, so did speculation, some serious, some far less so, about what exactly this object was. Its unusual trajectory, its tilt relative to the plane of the solar system, its speed, and its strange behavior near the sun fueled public curiosity that stretched well beyond ordinary science circles. Eventually, the search for technosignatures, signals or anomalies that might hint at artificial origin, was conducted using the instruments of the SETI Institute. Their conclusion, no such signals were found. 3I Atlas is not an alien construct. It is, by every available measurement, a natural interstellar comet. But the fact that scientists felt compelled to formally check tells you something about how strange this object's behavior seemed compared to anything we've cataloged before. The real story is not extraterrestrial engineering. The real story is far more unsettling in a quieter way. Our solar system has almost certainly been visited by interstellar wanderers many times before, and until very recently, we had no way of knowing. We simply weren't watching closely enough. Rubin changes that equation completely, and this is where the second layer of this story begins, the part that goes far beyond one comet, Because 3I Atlas was never the actual mission. It was a preview, a glitch in the calibration schedule that happened to catch history's third known interstellar visitor by accident. The real purpose of Rubin Observatory is something far larger and far more permanent. For the next 10 years, Rubin will scan the entire visible southern sky roughly every 3 to 4 nights, generating what scientists describe as the most detailed time-lapse movie of the universe ever assembled. A living record capturing asteroids, comets, exploding stars, shifting galaxies, and transient events that flicker in and out of existence in ways no previous instrument could reliably catch. In just the first month and a half of early survey operations, Rubin identified more than 11,000 previously undiscovered asteroids, including 33 near-Earth objects and hundreds of distant trans-Neptunian bodies drifting far beyond Pluto. For comparison, all other observatories on Earth combined typically discover around 20,000 asteroids in an entire year. Rubin is expected to find millions within its first 2 years alone. Millions. Read that again. An object detection rate that dwarfs everything humanity has accomplished in the history of organized astronomy, achieved in months rather than decades. And near-Earth objects are only one layer of what's being tracked. According to the scientists overseeing the mission, Rubin is expected to become the most effective observatory ever built for detecting interstellar objects specifically, meaning 3I Atlas's accidental discovery may end up being remembered not as an anomaly, but as the very first entry in a catalog that could eventually include dozens of similar visitors. Some models estimate Rubin could detect an interstellar object passing through our solar system as often as roughly once a year, compared to the mere 3 confirmed detections humanity has made across the entire span of modern astronomy up until now. Think about the shift that represents. For over a century, an interstellar visitor to our solar system was treated as a once-in-a-generation event, cause for global fascination and scientific scrambling. Rubin is expected to turn that into a routine annual occurrence. What was once nearly mythical is about to become expected. And once something becomes expected, the real question changes. It stops being, will we find another one, and starts being, what will we do when we find something we can't explain? This is also where the deeper ambitions of the observatory come into focus. Rubin isn't only a solar system watchdog. Its primary scientific mission is aimed at something even larger, the search for answers about dark matter and dark energy, the two forces that, according to current understanding, make up roughly 95% of everything that exists in the universe, while remaining almost entirely unexplained. Vera Rubin, the astronomer this observatory is named after, spent her career gathering evidence that galaxies were being held together by something invisible, something scientists still cannot directly detect or explain. This observatory carries her name because it was built, in large part, to finish the question she spent her life asking. By capturing repeated, ultra-precise images of the same patches of sky across 10 years, scientists hope to track how galaxies bend light, how they cluster, and how they drift apart at accelerating speeds. Clues that could finally begin explaining what dark energy actually is, or at least narrow down which competing theories deserve to survive. This is not a small ambition. This is one of the largest unresolved questions in modern physics, and Rubin was purpose-built to attack it with a scale of data no human institution has ever gathered before. And there's still another mystery waiting in the wings, one that has haunted planetary scientists for over a decade. Somewhere in the outer reaches of our solar system, beyond Neptune, subtle gravitational irregularities in the orbits of distant icy bodies have led some astronomers to theorize the existence of an undiscovered 9th planet, sometimes referred to as Planet 9. A hidden world potentially several times the mass of Earth, orbiting so far from the Sun that it has evaded every telescope built to look for it so far. Rubin is now expected to provide the most credible chance yet of either confirming or ruling out this planet's existence, according to scientists tracking the project's early survey data. If Planet 9 exists, and if it's out there hiding in the dark reaches, Rubin is now sweeping night after night. We may be closer than ever to finally seeing it, or just as significantly, closer than ever to finally proving it was never there at all. But here's where the tone of this story has to shift, because uncovering the universe's secrets always comes with tension attached. A machine capable of generating 7 million nightly alerts, cataloging millions of previously unknown objects, and detecting interstellar visitors that once slipped past us unnoticed also raises an uncomfortable question that isn't being discussed nearly enough. If an object like 3I Atlas could sit undetected in raw data for 10 days during a mere calibration phase, how many similar objects passed through our solar system in the decades before Rubin existed, completely unnoticed, with nobody ever knowing they were there at all? What most people are not seeing is that this isn't really a story about one comet. It's a story about how blind we've been until now, and how quickly that blindness is about to end. For the entire history of human civilization, we've been assuming a level of safety and predictability about our solar system that was never actually earned. It was simply the result of never having the tools to look closely enough to be worried. Rubin represents the moment that excuse disappears, but the more important detail is not the safety of those particular 7 rocks. It's the sheer speed at which they were found, a volume of discovery achieved in a single test night that used to take entire observatories years to accumulate. And this is where the future uncertainty begins to take shape, because the honest truth is that nobody, not even the scientists running this observatory, can predict exactly what 10 years of uninterrupted, full-sky, high-precision monitoring will eventually reveal. Every past leap in observational technology has produced discoveries nobody anticipated in advance. When telescopes first turned toward the outer solar system in earnest, we found entire populations of icy bodies we didn't know existed. When surveys scanned deep space more precisely, we found galaxies we didn't know were there, exploding stars we didn't know were happening, black holes we didn't know were feeding. Every time our instruments got sharper, the universe got stranger. There is no reason to believe this pattern stops now, and there is every reason to believe Rubin, watching the sky with unprecedented persistence, night after night, for a full decade, will eventually catch something nobody currently has a framework to explain. Consider what's already sitting quietly inside the numbers. 7 million nightly alerts, millions of new asteroids projected within 2 years, a near certainty of catching multiple future interstellar visitors, some potentially larger, faster, or stranger than 3I our Atlas. A live hunt for a hidden 9th planet that may finally be within reach. And a foundational mission aimed squarely at one of the biggest blind spots in modern physics. The invisible 95% of the universe we still cannot directly see or measure. And underneath it all sits the quiet, almost eerie detail that started this entire story. The fact that an interstellar object slipped through Rubin's own cameras completely unnoticed for 10 full days, buried inside routine calibration data, before anyone realized what had just crossed our threshold. If that happened during a testing phase before the system was even fully awake, the real question is what else might already be sitting somewhere in that mountain of nightly data, waiting for someone, somewhere, to finally notice it. Because Rubin isn't just capturing images anymore, it's compiling a decade-long record of every unexplained flicker, every unexpected visitor, every gravitational anomaly the sky has been hiding from us in plain sight. Somewhere inside those 7 million nightly alerts, among the millions of newly cataloged objects, there may already be something extraordinary sitting quietly in the archive right now, unflagged, unnoticed, waiting exactly the way 3I Atlas waited, for 10 days, before anyone thought to look. The legacy survey of space and time has only just begun. 10 years remain. And if the very first days of this observatory's operation were enough to accidentally catch an interstellar visitor slipping past our defenses unnoticed, the only honest question left to ask is this: what is Rubin about to find next? And are we actually ready to understand it when it does?